In this ACT video, we're going to look at segments within circles. And here we have a circle, and I went ahead and listed the definitions for you and our three types of segments. You've heard these words before. Radius, definitely heard that one. Chord, you may or may not be familiar with. And down here is diameter. And the definition of a radius is a segment with endpoints on the center of the circle and a point on the circle. So let's look over here to the right. We have circle O. O is our center. So let me put a dot there just to kind of make that stand out. Circle O. And the radius, well, actually we have infinitely many radii in the circle, and we've got 3 of them labeled. So the most obvious might be line segment OC or CO. But we can also call AO a radius, and we can also call OB or BO a radius. So there's 3 radii. Radii is plural for radius, and we can list them. Remember, those are just segments, and so AO, OC, OB, and remember with segments AO, OA, it's the same thing. Doesn't matter the order that you write the letters. Now, a chord is a segment with endpoints on the circle. So I only have one chord drawn here for you, and that is this one right down here. Let me highlight that in yellow. And that's DE. And it's not going to go through the center. If it goes through the center, we call it something else. And we're going to do that in a minute. So here our chord is segment DE. And there's all sorts of relationships going on here with these different types of segments, and that's what we're going to look at next. But lastly, we need to look at the diameter. And the diameter is the chord which contains the center. So the diameter is a special type of chord, and you may not think about it like that, but it is. And I'm running out of colors, so what if I just go back to this blue color? That whole segment AB. That whole thing is a diameter. That's the only diameter I drew, but we could draw infinitely many diameters. So let's list that as segment AB. Remember, it's going through the center. So we have radius, we have the chord, and we have the diameter, 3 types of segments within the circle. These are just some that I drew for you. We could draw infinitely many of all of them. Now, what we want to look at with these segments is intersecting chords. If 2 chords intersect inside of a circle, then the products of the measures of the parts of each chord are equal. Okay, so we know product means multiply. And what happened here is this chord with parts A and part B, let's call this the blue chord. Didn't make the straightest line, but that's okay. It intersects with AB, which we'll call this purple chord. And so the product of their parts, AB, is equal to C times D. Let's do an example with this with some actual numbers. That may help. Let's find the value of X. So again, we have 2 chords intersecting inside this circle. And maybe if I turn this on, it'll work better. Let's do green. So those pieces are X and 5. And then we'll do yellow for this chord, 3 and 7. So you just set the products equal to each other. So that would be 5 times X is equal to 3 times 7. So 5x is equal to 21. Divide by 5 on both sides. And x is 21 over 5, or you might want to write it as 4.2. It's the ACT review video, so on the ACT, you'll want to look at your answer choices. Again, don't spend a lot of time doing extra work that you don't have to do. If they have 21 over 5, then you just want to pick that one and move on because you want to use that time for other problems. So radius, chord, and diameter, different segments within the circle.